All right, Unit 3, video number 8 is all about explicit functions. Now, these are going to go with that recursive, but it is a different type of formula. So you're going to have to really get this down as well, okay? To write an explicit function in the arithmetic, number 1, determine if the sequence is arithmetic, okay? So do you add or subtract the same amount from one term to the next? Number 2, find the common difference, the number you add or subtract. And number 3, create an explicit formula using the pattern of the first term added to the product of the common difference and one less than the term number. And that's what we have right here, okay? That's what this is. This says f of n, so the function of whatever n is equal to a sub 1, first term, plus d, that common difference, parentheses, n minus 1. And we're going to be finding a certain value for n. And if you need more help on arithmetic sequence, see video number 4 in Unit 3 for an entire lesson on it. Now, to write an explicit function that is geometric. So we're talking about multiplying. Step 1 says determine if the sequence is geometric. Do you multiply or divide the same amount from one term to the next? Number 2 says find the common ratio, the number you multiply or divide. And number 3 says create an explicit function using the pattern of the first term multiplied by the common ratio raised to a power of one less than the term number. That's what this is. F sub of n is equal to a sub 1, the first term, times r, that common ratio, raised to the power of n minus 1. If you need more help on geometric sequences, see video number 5 in Unit 3 for an entire lesson on geometric sequences. All right, so example 1, write an explicit function for the following sequence: 10, 15, 20, 25, 30, 35. Okay, so step number 1, tell me what kind of sequence it is. Is it arithmetic or is it geometric? Well, this is arithmetic because you are adding 5 each time. So it is a linear arithmetic sequence. Step 2, you might want to set a table. Okay, so here's my n, which my n's are just 1, 2, 3, 4, I think I went up to 6, 5, 6. And this is my f of n, so my function of n, which is my 10, 15, 20, 25, 30, 35. Okay, so I created a table just so I could see that visual. If you need to see the subscripts, remember this is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5, a sub 6, if I need to see it in that subscript. Step 3 says choose the appropriate formula. Well, since I decided it was arithmetic, f of n is equal to a sub 1 plus d to the times n minus 1. Okay, so now I need to identify what my a sub 1 is. Well, a sub 1 in this case is equal to 10. My d in this case is equal to a positive 5 because I'm adding 5 each time. So now I just need to put it in the formula. So f of n is equal to 10 plus 5 to the n minus 1. So now I just need to keep distributing through 10 plus 5n minus 5, combine like terms, and I get 5n plus 5. And that would be my explicit function for this sequence. All right, example 2 says write an explicit function for the following sequence: 3, 6, 12, 24, 48, 96. So step 1, determine if it's arithmetic or geometric. Well, it is geometric because we are multiplying something each time. We are doubling these. Step 2 says go ahead and create a table. So we have n column and we have f of n column. So we have 1, 2. So 1, it's at 3. 2, it's at 6. The third term is at 12. The fourth term is at 24. The fifth term is at 48. And you get the pattern, okay? Step 3, choose the appropriate formula, which since we have geometric, we go with the geometric, which is a sub 1 times r to the n minus 1. Step 4, really, it's identify the a sub 1, And r, a sub 1 equals 3. R in this case equals 2 because I'm multiplying 2 each time. And then I just need to plug it into that formula. So f of n is equal to 3 times 2 raised to the n minus 1 power. And I can't do anything else with that. I can't combine things because that 2 has that n minus 1 power to it, so I can't multiply it by 3. So that would be done. All right, example 3 said write an explicit function for the following sequence: 3, 7, 11, 15. So I went straight into formula mode because, again, I know my a sub 1 is equal to 3, and I know my difference. I'm adding 4, and notice I'm adding, so it's arithmetic. So I went to the formula, which is f of n is equal to a sub 1 plus d to the n minus 1. So f of n is equal to 3 plus 4 to the n minus 1. We need to distribute. F of n is equal to 3 plus 4n minus 4, which ends us with the equation 4n minus 1. All right, and example 4 said write an explicit function for the following sequence: -12, -7, -2, and 3. So again, I've determined right away these are being added. So I have my a sub 1 term is equal to -12. My d, because it's being added, is a positive 5 because I'm adding 5 each time. So I choose that formula, which is a sub 1 plus d times n minus 1, and I start plugging in what I know. I know this equals -12. I know the d value equals 5. I don't know my n at this current time. I'm just writing an equation. I'm not doing more than that. So I'm distributing through. And now I'm combining like terms. And I get 5n minus 17 is what is equal to my f of n. That would be the explicit function.